Good morning, students. Last class I told about vectors. I have finished all types of problems of vectors. I told how to find out cosine of angle between the two vectors, sine of angle between the two vectors, and how to find out area of triangle with help of two adjacent sides, area of parallelogram with help of two adjacent sides, and area of parallelogram with help of two diagonals, and also how to find out volume of parallel pipe, that is scalar triple product value. Even I told some standard conditions how to show the given 3 points are collinear and coplanar in case of vectors. Like that I have finished all types of problems from vectors. Now today we will start one new lesson, that is three-dimensional geometry. This is three-dimensional geometry. Three-dimensional geometry. Here, in case of three-dimensional geometry, here also we are going to applying some concepts of vector applications. That's what, after completion of vectors, we choose this chapter, that is three-dimensional geometry. By seeing this name, three-dimensional geometry is there. Three means we will see here three axes. In case of two-dimensional geometry, in that just we will see only two axes, that is only one plane was there. But here in this case three-dimensional geometry, we will see different types of planes and different types of octants. Like totally we will discuss about space. In case of two-dimensional geometry, the points will come in plane. Here in case of three-dimensional geometry, the points will come in space. Like that the difference between two-dimensional geometry and three-dimensional geometry. Same applications what we applied in two-dimensional geometry, here also we are going to applying the same applications, but here one is extra, one coordinate will come extra here. At the same time, three-dimensional geometry means here there is a little bit relationship is there between vectors and three-dimensional geometry. When you are going to solving the problems of three-dimensional geometry, in some problems they will ask both methods, Cartesian method and vector method. That's what here we need some applications of vectors also here. And firstly we discuss about three-dimensional geometry means, let us will see the diagrammatically three axes we'll see here. It is y-axis and it is x-axis, and upside is z-axis, and O is the point of intersection of x-axis and y-axis, x-axis, y-axis and z-axis. So just extend that x-axis like this, it is xo x dash, one line, and extend here y-axis also, it is yo y dash. Now extend z also, zo z dash here. All the three axes are mutually perpendicular to each other. All the three axes are mutually perpendicular each other, and O is the origin here, that O is the point of intersection of all the three axes. This system, whole of this system is called rectangular Cartesian coordinate system. Rectangular Cartesian coordinate system. This is Cartesian coordinate system. Including all the three axes, xo x dash, yo y dash and zo z dash. These three axes mutually perpendicular and intersects at the point O, and where O is called origin. This including all the system, all the system of all three axes is called rectangular Cartesian coordinate system in 3-dimension space. In 3-dimension space we are calling this rectangular Cartesian coordinate system. Only two axes, x and y axis, means we are calling that rectangular coordinate system in 2-dimensional space. It was there in first PC. Now in case of 3-dimensional means we need 3 axes. That's what, by seeing the diagram easily we can analyze. XO x dash is x axis, YO y dash is y axis, ZO z dash is z axis, and O is called origin here. Like that we'll see like all the 3 types of names here from this diagram. This diagram will come in space. Space means we consider a room, a single room, it is also considered as a space here. And after completion of all these axes, just we'll see here how many number of planes, how many number of octants will come. Let us will discuss about planes and octants here. Next one is planes. What are the planes and what are the octants here? Planes. See here, planes and octants. And octants here. Planes and octants. See, if you can consider a room is a space, means that space is divided into 6 planes and 8 octants. For example, if you can take a room, in one single room 4 walls, and above floor also one plane, and above that part is also one plane. Like that totally will get 6 planes. 4 walls means opposite 2 walls. For example, one wall and one wall, they are opposite to each other, like the 2 planes. Another 2 walls, they are opposite to each other, those 2 also considered as 2 planes. Down floor, and floor is also one plane. Above, upside, it is also one plane. Totally 6 planes will get here. That's what finally we can tell that space is can be divided into 6 planes. That planes means those 6 planes are prepared by or covered by 3 axes only. Those 3 axes means, for example, y and z axis contains y and z axis contain a yz plane here. Next, z and x axis contain zx plane or xz plane, zx plane. Or x and y axis contain xy plane. Like that here different types of planes will get in space. YZ plane, y and z axis contains. Zx plane, it contains zx axis. XY plane, it contains x and y axis. That corresponding to plane, same axis will get here. Here YZ, x is not present. X is not present means that plane contains y and z axis. Here zx plane, in this y is not present here. That's what zx plane contains z and x axis. Here xy plane here z, we are not seeing the term z here. That's what xy plane contains x and y axis only. Or if we can reverse zy, xz, yx, like that some other planes also will come. For example, xy is positive, then yx is negative direction. Then zx is plane xz and yz is plane and zy. Like that we will get 6 planes are there. According to plane, same according to those letters, those axes only present here. Like that we'll get planes in the space. That's what finally we can tell that space is divided into 6 planes. Next come to octant here. That's why these 3 planes are mutually perpendicular to each other. And these 3 planes are xz plane, yz plane, zx plane, xy plane. These 3 planes are always mutually perpendicular to each other. These are all rules under rectangular Cartesian coordinate system, because these are all informations about rectangular coordinate Cartesian system. Next come to octants. Octant means, you'll see this, simply we can tell corners of the room. Wherever if we can see the coordinates in room, that coordinate is called one octant. See, where the 3 axes meets at one point, we'll get one octant. Say in a room you will see 8 corners. Each corner is one octant. Each corner is one octant. For example, diagrammatically I am showing here z axis and here y axis and here x axis. That's what they are mutually perpendicular to each other. It is one octant here. Wherever negative direction, one more octant will get. Another negative direction, one more octant will get. Like that, according to octant, we'll get coordinate of a point also here. Coordinates of a point also here. See how we'll see that 8 octants in space means. Let us will discuss about octants here. Totally just now I told 8 octants will come. I told no. How we'll get those 8 octants? Let us will discuss about those octants. I am telling about all these 8 octants here. I am going writing 8 octants here. They are, one is OXYZ, one octant. OX dash YZ, one octant. OXY dash Z. OXYZ dash. And the 4 remaining 4 are OX dash Y dash Z. OX dash Y Z dash. Next, OX Y dash Z dash. OX dash Y dash Z dash. Like that we'll get 8 octants. 1, 2, 3, 4, 5, 6, 7, 8 octants here. But 8 in all 8 octants, how are the symbols of coordinates of a point here? About that also we must and should discuss here. 8 octants, and I told about planes also. And finally, that the space is divided into 6 planes and 8 octants. But now we'll discuss about how we can allot the signs to coordinates of a point here. Then we must and should discuss about signs of coordinates of points corresponding to the octants here. First, in this, by taking a table, I'll tell you one table. According to the table, we can tell that symbols of, that is signs of coordinates of a point corresponding to the octants. See here, by seeing this table, easily we can analyze. It is one table here. One is octant here. octant here, coordinate here, coordinate here, coordinate here. First one is x coordinate here. X. What is the symbol of x coordinate? What is the symbol of y coordinate? What is the symbol of z coordinates? According to octant, we shall allot the sign to coordinates. O x y z. First one is O x y z. In this, second coordinates O x dash y z, O x y dash z, O x y z dash, O x dash y dash z, O x dash y z dash, O x y dash z dash. Last one is O x dash y dash z dash. Total 8 will come. 1, 2, 3, 4, 5, 6, 7, 8. But in this first octant, let us we'll discuss about signs of coordinates in first octant. See here, one thing we must remember here, if there is dash means instead of that coordinate we should write negative symbol. If there is no dash means corresponding to that coordinate we should write a positive symbol, that is plus. Now let us discuss about octant OXYZ. There are no dash symbols to all these three. That's what we can write. All the three are positive here. Next come to OX-YZ here. OX-YZ here. Here dash is there for x. That's what x coordinate can be considered as negative but remaining two are positive. Come to OXYZ. There is dash for y, that is negative, and remaining are all positive here. Next dash is there for z. That's what z can be considered as negative but remaining two are positive, that is plus. Next come to octant, next octant here, that is OX dash y dash z here, OX dash y dash z here. Dash is there for x and y, they are negative terms and remaining is positive. Dash is there for x and z, that is the coordinates of x and z are negative but middle is y coordinate is positive. Dash is there for y and z, that is y and z are negative but there is no dash for x, that is positive. Dash is there to all the three coordinates, that's what all three coordinates can be written as negative. Like that we are going to allotting the signs to the coordinates of a given point according to the octants. Like that we allot the signs to the coordinates of given point according to the octant here. How means the question, they will ask one question here on this table, based on this table, simple questions they will ask, and one is for example here, the point P 2, 3, 5 lies in which octants? When they will ask question lying a point according to octants, just if you can observe all the coordinates of given point, whether they are positive or negative, we must and should check here. Here in this point +2, +3, +5 is there. That's what all or plus means which octant? OXYZ. Therefore this point is lies on OXYZ octants, belonging to OXYZ octants. For example, one more example here. The point P -2, 5, 9 it is belong to which octants? Now, if you can observe, signs of coordinates of given point P, one of the x coordinate is negative -2 and remaining y and z coordinates are positive. That's what it is lies in. It is lies or it is belonging to ox dash yz octant. That's what it is, ox dash yz. Third example, 5, 3, -2. Here, if you can observe, the z coordinate is negative. The z coordinate is negative, remaining x and y are positive. That's what z coordinate is only negative means oxyz dash octant. That's what the point P 5, 3, -2 belonging to oxyz dash octants. Like that, based on the signs, whether positive or whether they are negative, according to those signs we are going to allotting the octants based on this table here. That's what even I told about planes and octants. 6 planes and 8 octants here. Next we'll discuss about how whenever the points lies on planes, the points lies on axis, then how are the coordinates of points corresponding to planes and corresponding to axis. Like that, now we'll discuss some important points under 3-dimensional geometry, and based on those rules of octants and planes here. Let us, planes is very important points here. In case of 3-dimensional geometry, all the distances measured from origin only to all the x-axis, y-axis and z-axis, or the parallel to any axis lines also. All the distances are measured from origin only. For example, take here z-axis, x-axis, y-axis, z, and here x-axis is there. All the distance measured from, for example, OP is there, P, it is one point P, x, y, z you can take here. The distance from O to P, to this line, the distance from O to P, the measured from origin only. Or if you can take one line parallel here, like this, you can take one line AB parallel. For this also, the distance from origin only measured from A to B. That's what you can take. For example, one more point you can take here, A here, C some point. The distance from O to C is there. Small letter A is there. The distance from O to C point on x-axis, that is measured from origin only. Otherwise, if you can take one line parallel to AB, this distance also C, that is also measured from origin. That's what finally we can tell all types of distances measured from origin to any point on axis or to any line parallel to axis. That's what finally we can tell all the distances are measured from origin only. Next, second point. If any point lies on x-axis, whenever the points lies on axis, how are their coordinates? How we can write their values here? X-axis. See, for example, here A is there. That A is lies on x-axis. That point lies on x-axis means will not get the values of y and z. That's what remaining values of y and z, they becomes 0 here. That's what finally we can write A coordinates as A, 0, 0 here. That's what any point lies on x-axis. Any point lies on x-axis, is always in the form of capital A, a comma 0 here. Similarly, if any point lies on y-axis, if any point lies on y-axis here, see here, lies on y-axis means just we'll take x and z as zeros. Here we can take capital B, then we can write 0 comma b comma 0 here. That's what we can tell. The coordinates of x and z are zeros. If any point lies on y-axis, the values of x and z are zeros. That's what we can tell. Any point lies on x-axis is always in the form of b 0 comma b comma 0. That's what if they can lies on y-axis, the values of x and z are zeros. Fourth, lies on z-axis. Z-axis. Just to consider a point C on z-axis here. Here z-axis means will not get the values of x and y, that is 0 comma C here. That's what if any point lies on z-axis is always in the form of capital C 0 comma C here, where I represented some alphabetically. I have taken small letters here. Small letter A means distance from O to A. Small letter B means distance from O to B. And small letter C means distance from O to C. There lies on axis x comma y and z axis respectively. Like that, we are going to giving the values if they can lies on the axis. That is, if it can lies x axis, then y and z are zeros. If we can lies y axis, x and z are zeros. If we can lies on z axis, x and y are zeros. These are the rules on axis. Next, what about planes here? Planes. In case of planes, let us discuss about the planes also here. If any point lies on yz plane here, yz plane here. YZ plane means here will not get x term. X term means instead of x will take 0, then the point becomes on YZ plane 0 comma b comma c here. Because in YZ plane we are not getting a x term here. When you are not getting the term x term means corresponding to that in that first coordinate place will take 0. That's what any point lies on yz plane, then z coordinate is x coordinate is always 0. Sixth, zx plane. If any point lies on zx plane, by seeing this zx plane will not get y term here, will not see the y term here. When we are not seeing y term means instead of that we should write 0. That's what here in this case point becomes a comma 0 comma c here. Instead of y I have written 0 here. That's what the point lies on zx plane here. Seventh, if any point lies on xy plane here, xy plane here, in this xy plane we will not see the z term. If you will not see the z term means instead of z we must and should take 0, then we can write coordinates of any point lies on xy plane. It is in the form of phase a comma b comma 0 here. Like that we are going to take the points on the planes. Corresponding to plane we are going to writing the values of x comma y and z is all are also zeros here. When it lies in yz plane, x has 0. When it lies in zx plane, y has 0. When if it lies on xy plane, z has 0. These are the, before that I told rules of axis, and before that I told measurement of distances. All the distances measured from origin to any line to any point on x-axis or y-axis, z-axis, or parallel to those axes also here. Afterwards, I told rules of the points when they lies on axis. And after completion of this, just now I told about the planes when the points lies on the plane and which are zeros and which are not zeros. I told about these also. Next, last one is 8 images. First one is image of the point. Under the 8th, I will give the 3 points here. Image of the points. Image of the points. Image of the point in YZ plane. First one is in YZ plane. B here point we can take P, A, B, C in first in YZ plane. In YZ plane means here we will not see the x term. Image means opposites. That's what we must take opposite symbol to x coordinate. In YZ plane, its image becomes capital A minus A, B, C here. Second one is in ZX plane here. ZX plane will not get y term here. That's what opposite symbol to second quadrant of given point A, B, C. Then its image in ZX plane becomes capital B. We can write A, minus B, C here. Third, XY plane. In XY plane, will not get the Z term. Z term means third coordinate. We must take opposite symbol to third coordinate. That's what in XY plane, image of the point P, A, B, C can be written as A, B, minus C. Like that, we are going taking images of the given point according to the given planes. It is which types of questions they will ask here in case of planes and images. Let us we'll discuss about those problems also here. See, first one is, for example, questions, examples on planes and images. One. Point 2, 3, 0 lies in which plane? When they are asking lying of the plane corresponding to the point means in this point which is 0, z coordinate as 0. When z is 0 means it is belonging to which plane? XY plane. That's what here it is lying in XY plane here. Like this. Second question. 2, 0, 5. It is belong to which plane? Here, if you can observe, y coordinate is 0. Y coordinate 0 means it is belonging to which plane? Here, say this. Y coordinate 0 means ZX plane. That's what we can write this ZX plane. This is. Next, third is space 3, 5, 0. It is belong to which plane? Z is 0. Z is 0 means which coordinate? It is XY plane. Or we can write one more example. Space 0, 5, 2 here. Which is 0? X is 0. X is 0 means x is becomes 0 means it becomes 0 in which plane? YZ plane. That's what this point is lying in YZ plane. These are the examples on the planes. The points lies on the which plane. Which plane means according to which coordinate 0. Based on that, we can allot the plane to the given point here. Next, images. The image of the points. The image of the point. The image of the point P 2, 5, 7 in XY plane. XY plane here. In XY plane, what we have formula? The image of the point P A, B, C in XY plane. A, B, minus C. That is third coordinate is negative. Opposites. Image means opposite to that given point. That is, we can write Z is not there. We must and should take opposite to that third coordinate. Then in XY plane, its image is 2, 5, minus 7. Like that, we are going taking in coordinates of image in that plane. Otherwise, if they can ask YZ plane, then image of this point, how we can write? How we can take that coordinates of image of the point P 2, 5, 7 in YZ plane. In YZ plane, if you can observe the formula, image of the point P A, B, C is capital A minus A, B, C. That becomes, for B we can write here minus 2, 5, 7. Otherwise, you can take in XY plane also. XY plane also we can take here. XY plane, if you can consider, in XY plane already I told, next plane is the XZ plane. In case of XZ plane, see here, ZX or XZ both are considered same planes here. In XZ plane, which is negative? Second coordinate is negative. That's what, according to that formula, image of the point P 2, 5, 7 in XZ plane is 2, minus 5, 7. Like that, we are taking images and lying of the points on the planes also. Next, afterwards, distance between the 2 points, section formula, and midpoint formula. Already we knew about all these 3 formulas in first PC. And what is the formula for distance and what is the formula for section formula? In first PC, we derived the proofs of distance formula and sectional formula. Section formula is divided into 2 types. One is internal section formula and the one is external section formula. At the same time, along with that, midpoint formula is also there. First one is the distance formula. Distance formula, this is. Distance formula means a line segment joining of the 2 points like this. Pace x1, y1, z1 and q is x2, y2, z2. You considered capital D is the distance between P and Q here. Then D is equal to, we can write here square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. It is the distance between the 2 points. Even it has came in first piece also. In first piece also we have the chapter 3-dimensional geometry chapter was there. in that chapter we derive this formula also, because we need concept of this to solve some questions in case of three-dimensional geometry. Next one is section formula. Section formula. Section formula. A line segment joining of the 2 points A and B. A is x1 comma y1 comma z1, and B is x2 comma y2 comma z2. A division point will take here P here. P divides the line segments. P divides the line segment AB in the ratio m:n. Then coordinates of P we can write P is equal to mx2 plus nx1 whole dividing by m plus n, my2 plus ny1 whole dividing by m plus n, mz2 plus nz1 whole dividing by m plus n. This formula is called internal section formula. Internal section formula this is. Internal section formula. How we can we are calling it as internal section formula means here the division point P divides AB inside between A and B. Division point will come. It divides line AB in the ratio m:n internally. That's what this formula is called as internal section formula. We have proof of this also in first PC. We derived also. But in second PC, no need of this proof, just we'll use in some problems we will use this formula. Next, external section formula. In case of external section formula, the division point will come outside of AB here. Say diagrammatically I am showing here A x1 comma y1 comma z1. Here you consider B here. B x2 comma y2 comma z2. But division point outside will come from outside. You can consider P here, the outside P. From outside the division point P divides the line segment AB. That's what A to P you considered here. You can take A to P you considered m parts. B to P you can consider some n parts here. That's what then the coordinates of P becomes P is equal to mx2 minus nx1 whole dividing by m minus n, my2 minus ny1 whole dividing by m minus n, z2 minus nz1 whole dividing by m minus n. It is the formula. This formula is called external section formula. External section formula this is. For this, the difference between internal and external is, in case of internal the division point will come inside of A and B. In case of external the division point will come outside of AB. In case of internal we will use plus. In case of external we shall use minus. That is the difference between internal section formula and external section formula. Midpoint formula here. Midpoints. By seeing this midpoint formula, In case of midpoint formula, the division point divides line AB into two equal parts. Whenever if we can the division point divides into equal parts, then the division point is called midpoint of the line segment AB. See, diagrammatically I am showing here. See, a line segment AB here. A is x1 comma, A is here x1 comma y1 comma z1. B is here, B is considered B, x2 comma y2 comma z2 here. Then division point here, P here. It divides into two equal parts. Then coordinates of P we can write. P is equal to x1 plus x2 whole dividing by 2 comma y1 plus y2 whole dividing by 2 comma z1 plus z2 whole dividing by 2, like that. This is the midpoint formula. This formula is called midpoint formula, and this formula is called externally section formula. This formula is called internally section formula. This formula is called distance formula. Like that, we will see here different types of formula. This formula is called a distance formula. This is because we'll use like all these formulas to solve some different types of problems in a three-dimensional geometry. This is the distance section formulas and midpoint formulas. Just now already I told about space. The space is divided into 6 planes and 8 octants, and how when we'll take 0, x coordinate 0, y coordinate 0 and z coordinate 0. If the lies on axis, how they are. If the lies on the planes, how they are. Along with that, I told the images, rules of images also, and just now I told different types of formulas, that is distance, section, and last one is midpoint formula. And next class we will discuss about direction ratios and direction cosines. Along with that, we'll solve different types of problems from 11-point exercise. Thank you very much. Thank you.